Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, today's topic is one that I've wanted to bring you for quite a while. Here it is. Using an Ethernet barcode reader with Horner OCS. Now, in order to do this topic properly, I needed the assistance of an industrial barcode manufacturer. So I talked to my colleague and friend Andrew Jagger from Powermation, and he recommended I talk to the folks at Datalogic. And they were kind enough not only to loan me some equipment for today's demonstrations, but also to agree to join us for today's session to provide us some information on their products. So you're not only going to learn how to interconnect Horner OCS with Ethernet barcode scanners, you're going to learn more about Ethernet barcode scanners. So I'm excited about that. All right. So before I bring the folks in from Datalogic, let's take a look at how we're breaking down today's topic. So we're going to start out by asking the question, why use Ethernet for barcode scanning? Then we're going to bring in the folks from Datalogic and learn about their product line. While following that, I apply their product with the Horner OCS using Modbus TCP. That's the protocol we're going to be using today. And we're going to have plenty of time for instruction and for demonstrations. Let's go ahead and get started. Why Ethernet for barcode reading? Well, traditionally, as many of you know, barcode readers have been serial devices, whether RS-232 or USB. And remember, USB stands for Universal Serial Bus, so it's still a serial device. For low-speed simple applications, a serial barcode reader can work just fine. If you don't have a lot of speed and you don't need a lot of distance, it might work for you just fine. However, a barcode reader as a serial device does impose some significant limitations. First of all, it's a point-to-point connection, and it's difficult to scale up. If you need to add more and more barcode readers, it means more and more serial ports or USB ports. Not easy to scale up. And the serial connection is a fairly low bandwidth one. So that means that more than likely, you're going to be getting just the barcode data and nothing more. What else could you possibly need? Well, if you're using a Ethernet-based barcode scanner, you could get some additional information alongside the barcode data that you're after. You could do sophisticated configuration over Ethernet. You could see history of barcode scans. You could see image data live and stored in some cases, and much more. But the bottom line in terms of other advantages also includes the ability to easily scale your system up, easily add additional barcode readers to your system, because obviously you can add multiple devices over Ethernet quite easily, and Ethernet has the higher bandwidth that's appropriate for multiple readers. Okay, so before we continue on and talk about how to integrate a barcode reader with a Horner OCS over Modbus TCP, we're going to bring in our guest today, Fabio Peruzzi, who's the Application Engineering Manager for Datalogic. How are we doing today, Fabio?
Doing great, thank you. How are you doing?
I'm doing wonderful, and I really appreciate the demo equipment, the loan, and I also appreciate you joining us to share your information. So you ready to get started?
I'm ready.
All right.
So Datalogic have been in the barcode reading business for more than 50 years. We are present in the retail market, the manufacturing, transportation, and logistics, and healthcare. We have more than 1,000 patents. We have more than 3,000 employees around the world. We're present in every continent, in almost every country. We got a lot of manufacturing, again, around the world. We got some manufacturing facilities in the US, in Europe, and in East Asia. And this is a map that shows our presence. So originally, the company was founded in Bologna. Our founder is from Bologna, Italy. But we have manufacturing in southern of Italy. We got offices in Europe, offices in the eastern of the world, in South Africa, Australia. And in the US, we got our main office for industrial scanners in Hatfield, Pennsylvania, which is just 1 hour north from Philadelphia. We got a big office in Eugene, Oregon, and then we got other office in Texas and in California. Our product segments, we like to think we are the only company in the barcode reading world that do everything. So we do fixed retail scanner, mobile computer, we have RFID, machine vision, We produce small scanner for the OEM market. We have sensor and safety, handheld scanners, stationary industrial scanner, which is what we're focusing on today, and also laser marking system to mark barcodes on direct parts. This is the portfolio of the stationary industrial scanners. It's divided between imagers and laser. Laser scanners were very popular when I started about 20 years ago. Now they're a little bit going away, but they still have a market share. But most of the new applications are made with imagers, because the advantage of the imagers, as you will see later, is not only to read a barcode, but to provide all kind of additional information, like we were saying before, like saving images, statistics, and more information than the laser will give you. So this is the variety of product from smaller to bigger. You want a less expensive product for applications that are more compact and less slower. If you want to go fast and cover a big area, then you need to upgrade to the more expensive, more performing product. So the Matrix family is what we're going to focus on. The Matrix reader are 2D readers that communicate Ethernet and Ethernet IP. We have also serial communication, and we can also communicate all other form, which is Modbus TCP, DeviceNet, Profibus, any type of communication you have. They all share a DL code configuration software, which is a very intuitive HMI that allows you to program the readers and to have immediate feedback on the performance. So we focus on the Matrix 320, which is the latest addition to the Matrix family. There are two models that you see here. The model on your left uses the liquid lens. So we have a mechanism to change the focus with the electronic command. And the model on the right is the C-mount. The C-mount is you have some lenses that you have to mount and focus and configure. And then the focus cannot change. You have fixed focus for that application. But the C-mount allows us to use a 5 megapixel sensor, while with liquid lens, we have 2 megapixel sensors. So some of the highlights of the products, it's a smart, it uses a smart sensor, so we can detect low contrast images and still detect the barcode even if there is low contrast. We got a multi-core platform. So we got a dual processor that allows us to dedicate one processor to reading the barcode as fast as efficiently as possible, and the dedicated processor to image saving. When you have an imager, image saving is key. You might want to see the image in real time of what you're doing, or you want to use the images for forensic after the event. If you got the no-read, you want to be able to go and analyze the reason for a no-read or reason for a behavior that's not expected by looking at the images. One of the nice features of this product, and we'll see, is the 360-degree light, and we'll see it in the live demo. And it is a very powerful ring of light around the illuminator that turns green when you're successful and turns red when you're not. And you will see it in the live demo, how nice it is and what a nice feedback it is to have it on the reader.
Definitely. Always comforting when you see that green light happening when you're doing a machine setup, for sure.
And so one of the main applications of the Matrix 320, we use it for hands-free. So we have a couple of kits that Datalogic produces. The way we have the reader that you usually position overhead, and then it comes with a cable and a power supply. Everything is included, and a USB connector that connects to the computer the same as your handheld does. Because the idea is to replace the gun with this hands-free presentation. This allows you to have both hands-free when you read a barcode, instead of having one hand taken by the gun and the other hand that you can carry product. This allows you to go faster, especially when you got big or bulky products that you require both hands. So and having a USB connector, it communicates to the PC exactly like the gun. So from all the software upstream, it makes no difference to have a gun or to have a presentation Matrix 320. The last slide that I want to share with you is a visual feedback. So with any browser, you just type in the IP address of the reader, which is connected to Ethernet, of course, and it will come up with a window with different options where you can see the performance, you can see images live, you can have a diagnostic feedback, immediate feedback if something is wrong in the reader. Those green lights that you see on your screen will become yellow or red to indicate a problem. So you'll have an immediate feedback. You know how the reader is performing. You can see the barcode that is coming through, and that is not affecting the performance. So that they can all happen during production, during live production. this is one of the many advantages of the Ethernet barcode readers.
Fantastic. Wow. I feel kind of like I've only just barely scratched the surface of working with this product, but I really appreciate, again, loaning us the equipment so I can do the demo that we're going to do a little bit later. And I really appreciate all the details and the education you gave us on the latest in Ethernet barcode readers. So thanks a bunch, Fabio.
Thank you, Chuck. If there are any questions, I'll be on.
Terrific. And again, if you're watching this live, don't hesitate to give us questions in the chat section. We'll get those answered just immediately if we can. And if you're watching this on replay, give us your questions and your comments in the comment section. And whether it's us at Horner or whether we forward the question off to Fabio and the folks at Datalogic, we'll see that it gets answered. Thanks again, Fabio.
Thank you.
Okay, so for the remainder of our program, we're going to focus in on how do I connect the Matrix 320 barcode reader over Ethernet with the Horner OCS for an application maybe where I'm, doing barcode scanning in a material handling application or whatever the case may be. So what we're going to do today is we're going to utilize Modbus TCP as the industrial network among many choices that we use to interface between the Horner OCS and the Matrix 320. Why Modbus, for instance? Well, one of the benefits of Modbus is it's the most widely applied industrial Ethernet network among multiple manufacturers. So it's always a good choice when you're looking to get equipment to communicate between multiple manufacturers. Now, there are a couple things to look out for with Modbus. It's quite straightforward, but one thing to keep in mind when you're talking about barcodes and Modbus is that Modbus is an integer-based protocol. And the barcode data you're typically going to be receiving is going to be byte-based or character-based or ASCII-based, however you want to look at it. So you do have to take some care to make sure that the byte order is handled properly of the data that's written. Of course, Datalogic takes care of writing the data properly to the OCS, but as you handle that data, you need to make sure that the byte order is maintained properly. Okay, so in the application between the Datalogic and the Horner OCS, over Modbus TCP, we're going to do something that some people might think of as being a little backwards, but it does make some sense when you think about it. The Datalogic Matrix 320 is going to act as the Modbus TCP client, and the Horner OCS is going to act as the Modbus TCP server. So in that scenario, the Datalogic will be doing the reading and the writing and the polling in the communications relationship. Okay, so what will the Datalogic unit be doing? Well, obviously it's going to be acting as the Modbus TCP client. It's going to be reading some OCS bits that will tell it, or specifically one bit, that is going to tell it, hey, it's time to go into the reading phase. So that bit could be turned on by the OCS internally and read by the Datalogic device in response maybe to a photo eye turning on or something like that, so that the reader knows, hey, we need to actually start scanning to be prepared to read a barcode. Once that happens and the barcode is in its read phase, then it's going to read the barcode and then write the data. The barcode data that it reads is going to be written to internal OCS memory space, and a bit is going to be turned on also or written by the Datalogic device, telling the OCS that a good read has occurred. So the OCS, sitting there acting as a Modbus TCP server, is going to monitor that good bit that's been written by the barcode scanner so it knows it has new data, and then it's going to process the new data. Part of the processing it's going to do on the data is to take data that was written as integer data and copy it over to a byte array so it can be handled as ASCII data. So that's effectively what's happening here. Okay, we're going to start by talking about the configuration required in the scanner itself, in the Matrix 320, to set it up for Modbus. Now, what we're not going to do is to cover, how do I set up the Matrix 320 for other tasks? We're going to focus in on, okay, how do we get Modbus working on the Matrix 320? And then we'll turn our attention to the OCS side of the equation. So effectively, to get Modbus set up on the 320, we run the DL code software that Fabio talked about. And then one thing we have to do before we start, and this tripped me up a little bit, but luckily Nate from Datalogic on the chat line got me squared away almost immediately. And that is, when we're going to be working with any of the field buses that are available with the 320, we need to make sure that our user level is set to expert in the software. If it's not, we won't have access to any of the field bus setup. So make sure you set the user level to expert, and you can do that right there from the software. The next thing you're going to do is you need to communicate or connect effectively with the 320. Over Ethernet would be the most likely approach. So it's going to show up in the software along the left-hand pane there. You double-click on your scanner as it appears, and then you press the Open Device Configuration to go into configuration mode. Once you're in configuration mode, you get a menu that shows up along the top there with 1, 2, and 3 from left to right. And then you're going to focus by starting in on the reading phase. So you select reading phase, and then once you do that and you're in expert mode, then you can click on a field bus icon that will be there and effectively add a new field bus. And when you press that button, you're going to want to add Modbus client. That's what we're working with today. So once you've got Modbus client added as a field bus, you click on Modbus client, and then in the far right-hand side, you're going to get all the Modbus parameters show up that you need to configure to get Modbus TCP working. So let's start with the key parameters that need to be changed. Starting with the start register. So what is the start register? Well, by default, the barcode scanner will write the barcode data to Modbus holding registers 40,001 and forward. So if you enter a start register of 0, that represents an offset of 0, which means that the barcode data is going to go directly into Modbus holding register 40,001. Now, Horner OCS has a direct mapping of holding registers to internal Horner memory. Now, 40,001, that particular holding register, is mapped to AQ1, and almost certainly there will be a conflict with other analog output data or high-speed counter data or something like that if you use that offset of 0, that is the default. So what I did in my demo, and what will probably work for you, is a start register of 99. So that's an offset of 99, which means the barcode data is going to appear starting at AQ100. And almost certainly there'll be no conflict in that area. Number of registers is effectively the number of integers of character data that you want to receive in there. So in my example, I set it to 30 registers, okay, which is 60 bytes or 60 characters worth of information. So AQ100 through AQ129 is where the barcode data is going to be written by the 320. Next, we need to configure, let's see, the remote address of the Modbus TCP server, which is the OCS in this case. So it'll be the address of the OCS. And then we also need to configure a connection retry time in milliseconds. I set mine up for 3 seconds. That seemed to work very well. You could probably set it a lot shorter than that as well. So those are the basic Modbus TCP parameters for the 320. All right, so we still have some work to do. We need to do some I/O mapping, starting with the phase on. So what is going to actually put the scanner into read phase, the phase in which it's sitting there waiting to scan a barcode? Well, what you're going to do is you're going to, in the center pane, you're going to select phase on, press that button, and then in the right-hand pane, what's going to appear is all the different things that can cause the read phase to turn on. And you're going to select one of the Modbus bits there as the bit that's going to cause the scanner to go into read phase. Now, in my case, I selected the very first one, and that is not mapped to holding registers. That is mapped to input registers, so our input bits. So that in the OCS means I1 through I8. So those bits 0 through 7 on the screen there correlate to I1 through I8. So in my case, I made it I1. So that could effectively represent a real-world photo eye or something that's plugged into the OCS through I1, for instance. Once you've selected which bit you want to cause it into read phase, then you need to describe the action. And effectively, you want the leading edge of that bit to cause read phase to turn on. Now, what will turn read phase off? Well, that's the next slide. You click on the phase off button, and then you're going to select the very same bit that turned it on, but this time you're going to select trailing edge. So when that input bit turns off, you're going to leave read phase. Now, one other thing that's useful that Mitch, my local sales guy from Datalogic, one thing he recommended was that I basically also turn off the read phase with a good read. So you turn it on with the input bit being turned on, and then as soon as it has a scan that's successful, it will turn itself off and go out of read mode. A little bit of work left to do, and that is we've configured the input side of things, what puts the scanner into read phase. Now we need to configure the output bits that are being written by the scanner to the OCS that gives us status. And the two simple ones are good read and no read. So let's start with good read. So let's in the center pane again, but this time after we've pressed the output setup tab at the top, we press the good read button. And then again, we can map that to a particular Modbus bit. Now these will be output bits, and these are going to be mapped to Q1 to Q8. So 0 through 7 on the screen there matches Q1 to Q8. Now, in my example, I basically selected, I believe, the 7th bit to be used for good read, and that turns on whenever, or is written effectively or turned on whenever a good read occurs. And then I also configured it to automatically turn off on a timeout. 1 second, I believe, is what I have it configured for there. And then similarly, on the bad read, we also need to configure a different output that is the bad read output, again, correlating somewhere between Q1 and Q8. And we wanted to turn off automatically after a second or so. That's a good way to configure it. Okay, and then when we're done with that step, configuring the output, that's the last step in configuring the reader. At that point, we can save our file, we can save to the device, and we can exit the software, and things will just start running. That's my experience, at least. Okay, now on the Horner OCS side, remember, the Horner OCS is acting as the server, so there's a lot less to configure. You basically go into the hardware configuration, you click on the Ethernet port that is going to be acting as the Modbus TCP server. Once you've selected that particular Ethernet port, you need to make sure that your Ethernet addresses are set up like they normally would be, your IP address, netmask, etc. Once you've done that, all you have to do is check the checkbox for Modbus slave. Modbus server would be more appropriate, but it says Modbus slave. Click on Modbus slave, and you're pretty much done in 99.9% of the cases. There's some additional parameters you could change if you wanted to, but again, I don't think it's even worth mentioning because it's not going to be used very frequently. Okay, now what's going to happen at runtime? So at runtime, effectively the OCS is going to turn on the digital input bit that is being read by the 320. That's going to tell the 320 to go into read phase. Once that happens, the 320 is going to presumably read the barcode, write the data, the barcode data, to the AQ registers that again are mapped over Modbus. And once that's done, it's going to send a good read signal and write that to the %Q that's mapped over Modbus as well. And then after a second, that good read bit's going to turn off. So that's pretty much all there is to it. Now let's talk just for a second about data handling in the OCS. So remember, this barcode data, which is by its nature byte type data, is being written over Modbus, which is by its nature integer type data. So that means 2 bytes per integer. The Modbus spec is very clear in terms of the order in which the data needs to be written. It needs to be sent big endian, as they would say. All right. The OCS is going to store that data in integers. And if you're using register-based advanced ladder, that's kind of the older style Cscape advanced ladder, you don't need to worry about too much more. That's one of the advantages of register-based advanced ladder. The OCS will store the information as integers. You can use ASCII function on integer data. It'll automatically make sure the bytes are in the right order. There's really nothing more to do. Now, if you're using a variable-based language, which has all kinds of advantages, but takes a little more work when it comes to ASCII sometimes, like variable-based advanced ladder or like IEC, you'll need to unpack that integer data into a byte array. So that's something you'll need to do, and you'll need to take care that the bytes are handled in the proper order. But I've got an example program that you can use directly if you want to download it that handles that for you. Whether you're using a barcode scanner like the Datalogic, which writes everything in the proper order, or maybe some other device that gets the bytes swapped. Either way, you'll have the tools you need to be able to get them in the right order. All right, let's go ahead and do our demonstration now of using the Datalogic Matrix 320 Ethernet barcode reader. And we're going to start out in Cscape, and then we'll go to the bench and then back to Cscape again. Shouldn't take too long. It's really been pretty straightforward getting everything set up. Okay, so we're going to start from Cscape. And so we're going to start from Cscape. And what I have going here, we'll just quickly go through the Modbus configuration again. Again, there's not much to it. We hit I/O configuration for the particular LAN port that is going to need to talk Modbus TCP server. We make sure our IP addresses are set up and that Modbus slave is configured. There are some additional things you could change, but again, rarely are you going to need to do that. And so on the OCS side of things, that's about all that needs to be set up configuration-wise. Now, I did do some mapping. And again, this is variable-based advanced ladder that I'm using here for my demonstration. So let me show you some mapping that I've done of some variables. Okay, so the barcode data is being written starting at AQ100, and there are as many as 30 words worth of barcode data, or 60 characters. Okay, so AQ100 through 129 is where the barcode data is coming in. So I have mapped that to a variable called barcode integer. Okay, so that's where the data is coming in. Now my good signal that says, hey, we got a good read, that's coming in and being written by the 320 to Q7 through its Modbus map. And then the bad read is coming in through Q8. And I've got both of those bits mapped over to internal variables as well. Okay. So that's really all the basic configuration that needs to be done on the OCS side of things. When it comes to unpacking the integer data into byte data, we'll come back to that and take a look at that in a second. Okay, so now let's go to the bench. Okay, apologize for a little bit of echo here, but here's the Datalogic Matrix 320. Let's take a quick look at this guy. First of all, it's made of a metal alloy, so really constructed, very nice. It has, one of the nice features I really like about it is it has this built-in express user interface here. So it's just a single button and a series of LEDs. But if you just need to do a quick aim or a quick focus, you don't necessarily have to drag your computer out to the production floor or to fire up your computer to make that quick little adjustment. So that's pretty nice. Again, mechanically, this thing is built like a tank, a metal alloy construction. It's got some nice mounting holes on the back here to mount to a bracket in your application. Also, it's got a couple of connectors here in the bottom. It's got this multi-connector, which has a lot of I/O and serial port type connection. It still supports those. And then it's got this industrial Ethernet type connector over here. So again, M12 type connector suitable for being out and in the middle of it. Now it's also been applied here with my XL7. Okay, so both the 320 and the XL7 are connected to an Ethernet switch. All right, and my read phase bit, which is mapped to I1, right now for the demonstration purpose, that's only set up through just this switch on my I/O simulator. Okay, so when I flip the switch on the I/O simulator, it's going to turn on I1 and we're going to go into read phase. All right, and then I've got indicators here of good read and failed read for bits that are written from the barcode reader itself. And then my data is going to show up here on the screen when I read that. All right, so let's do a quick read. I'm going to go ahead and turn on and put it into read mode. Okay. And you can see that immediately you've got this indication that it's in the scanning process. Now let me go ahead and aim it towards the barcode, and it quickly turned green and illustrated that it had done the scan. My software actually makes the number go away after a few seconds. All right, let's do another read. Okay. Again, we'll cycle the read phase button, or the input one, which causes it to go into read phase. Okay, we have our good read, we have our barcode, and that's really all there is to it. Now, if for whatever reason you go into read phase, okay, let's go back out and go into read phase and you're not able to read the barcode, then you will get a failed read indication. All right, so that's really all there is to it from a runtime standpoint. Couldn't be simpler. Okay, now let's head back to Cscape and just talk about unpacking the integer data as bytes. So what do we need to do? Now, as I mentioned before, if you're using register-based advanced ladder, there's really not much to do. Even though the data was written in as integers, it's been put in the proper order by the 320, and all the ASCII functions will unpack it in the proper order as well. So there's really nothing else that has to be done. But if, like myself, you enjoy using some of the advanced features of variable-based advanced ladder, this is one of the scenarios where it causes you a little more work to get some of the other benefits. Okay, so what are we doing in this unpacking? Well, every time we get well, first of all, let me talk about byte order. Now, if you're using most Modbus barcode scanners, and certainly a good quality one like the Datalogic, then the data is going to be written, the integer data is going to be written in the proper byte order. But even if it's not, you can change this contact in my sample program to always off, and it'll handle reversing the bytes, because the barcode reader didn't do it properly. But if you're using a Datalogic, you can just leave this as an always on because it writes the data in the normal fashion. Okay, every time we get a good reading, we're going to turn on a one shot, and then we're just going to go through a loop, and we're going to unpack the integer data that was written by the barcode reader, and we're going to unpack that, and then we're going to copy it into a byte array. So we have if we scan up to the top here, let me go up a little further in my variable list. Okay, so barcode integer is where the data is coming in, and barcode byte is where I'm unpacking it to. So that's what's happening there. So I did use a little bit of a trick that I want to tell you about. When I'm going through the process of using indirect moves, as well as for unpacking the integer-based data and then packing it back in as byte-based data, say that 3 times fast, I did need to use a mixture of word and byte type functions. So to make that work, I actually did a little trick where I have an array, or it's not really an array, I have a word variable, which is going to contain each integer that gets unpacked as I go through the loop. It's mapped to a specific memory location, and I have a byte variable, which is just 2 bytes long because it's, again, 1 word total, that is mapped to the very same location. So that allows me to handle the bytes individually and have the same data that's represented in the words be handled in a byte type fashion as well. So a little bit of a trick there. Everything's well documented if you want to download the application and take a look at it. But as we basically unpack, as we go through the loop 30 times quickly and get the information placed in the byte array, when we're done with that, I've got a little bit of logic in here for displaying the results of the barcode read on the screen and then taking it away after 5 seconds. So that's pretty much all that's required. A little bit of extra work there to unpack the bytes. But again, if you're using register-based ladder, you don't even need to do that. So let's head back to our slides and let's do a wrap-up. So what are the advantages of using Ethernet-based barcode readers? Well, much easier to add multiple readers. It's got much more bandwidth, so it can certainly handle multiple readers just fine. And you've got a lot of additional tools at configuration time and at runtime. The ability to see live images, the ability to see stored images, those are all advanced features that you can get because of the fact that that data is available over Ethernet. That data is not going directly into the OCS. The OCS is dealing primarily with the barcode information, but that data is available for you to tap into from a web browser or elsewhere on the network. And specifically today, we talked about the Datalogic Matrix 320 with its flexible Ethernet options, including Modbus TCP, Ethernet IP, and many other protocols. And of course, today we focused on Modbus TCP. Okay, so this is the time in our program where I remind you we're here every Tuesday at 2 o'clock, whether we're fully live like we were today, or whether we are streaming a pre-recorded video and standing by live to answer any questions you have. We're celebrating our 10th year of Horner Lighting. Check out their great videos on our YouTube channel alongside our automation content. Here's a reminder that we are at Automate 2023 in Detroit in a couple weeks. And in talking to Fabio pre-show, he told me they're going to be there as well. He won't personally be there, but Datalogic will definitely be at Automate. So you can catch up with both of our companies at the Automate show in Detroit, May 22nd through the 25th. Next week, we're going to be talking about using the new IO-Link masters with Horner OCS. A lot of you have been asking for IO-Link for a long time. We had our launch webinar last week, and then we'll be talking technically about how to work with the products hands-on in next Tuesday's live stream. So if you haven't subscribed to our channel yet, don't hesitate. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time that we post a new video. Okay, so until next week when we're going to talk IO Link, let's all get out there and do us some good.